Hi, I'm Dr Tina Joshi. I'm a lecturer in Molecular Microbiology, which really means I'm a lecturer in infections. And today I'm here to talk to you about superbugs. So what we're hearing about is how superbugs have come into being, what they are, and how our science is going to battle back. So I hope you enjoy what I'm going to be talking about today. What we're going to learn is the following. What are superbugs? So you'll get to know that today. Why we need antibiotics. Why they don't work anymore, which is quite a big thing that's going on in the world right now. What this actually means. And something else as well, climate change. So climate change is really linked to this. It's really important. And we need to figure out what we can do about it. What can we do about antibiotics? What can we do about climate change? I'm going to give you some ideas today about how to do that. And at the very end, I'm expecting you to ask me some questions if that's okay with you guys. So superbugs, you can see them on the board. They are nasty organisms, and you can see them over here too. So for example, we've got varying superbugs. They could be bacteria, they could be viruses. The ones I'm focusing on today are bacteria. So you can see one here. This is MRSA. What's really great about MRSA is it's got loads of little nodules, like you see here. It's little balls, it's made out of little balls. But when it actually infects you, it can cause lots of skin infections, which isn't very, very nice. You've got some other ones here, and they've all got different shapes. So you can see this one, this is Salmonella. You can see how different that is compared to MRSA. But then again, you can see how different this one is to this particular microorganism here, which is Candida. What I want you to get out of this today is the fact that microorganisms look very, very different to each other. Hopefully you'll understand that if I say this to you, that this is another microorganism. It's got loads of little pointy things, and these little things here can make them move and move around the body, and that's what makes them dangerous to us. If they move around the body too much, and we can't protect ourselves from them, and medicines don't work, they'll make infections worse, and that means we'll get very, very ill. If we get ill and we can't actually have medicines that do work, that means essentially that we might not be able to survive. So it's quite a serious topic, this. So what are they? What are superbugs? They're basically microorganisms, microbes, germs, nasty things they are. So you can think about bacteria, and you can think about viruses, and you can think about things like fungi, like mushrooms. But they're not really mushrooms. Where do they live? They can live anywhere. They can live on your skin. They can live on this table over here. They could live on my lab coat over here. They're everywhere. That's where microbes are. How big are they? Microbes are tiny. So you might be wondering why I've got these toys here to show you. The reason I've got these toys here is because you can't see germs with your eye. You have to use something that's called a microscope, and we'll go on to that a bit later on. They're just so tiny, you just can't see them at all. Do they cause diseases? From what I've told you, yes, they definitely do. So there's our classic superbug. But what are microbes? So microbes are very, very tiny. You can only see them with the use of a microscope, as you can see there on the board. They're so small that only microscopes will magnify them. So it's like using a magnifying glass and looking at these little organisms you can barely see. And when you look at them, they could potentially even look like this under a microscope. They come in different shapes and sizes. So you can see this one here. This is really unusual. It looks like a chicken. This is actually chicken pox and a toy of chicken pox. You can see again how different that is to Salmonella, for example, and the way in which that's shaped. I want you to understand that they all have different shapes. They're found everywhere, and they're useful and very, very good for us. Some of them are, but some of them can make us very, very ill. So what are bacteria? What do they look like? I've got this really nice image for you. It can look a bit like this, like what I'm showing you today, but they also can have different shapes, different sizes, and you can see that the cartoon that I've got up shows you the eyes and crazy faces that bacteria can have. But really, that is what they look like if you drew a picture of them. They all have different names, so they have really, really long names. Things like the first one, which is Staphylococcus aureus, very, very long name. Things like Streptococcus pyogenes, they have like a big long name, so a big first name and a big second name, and that's how we do that in microbiology. So when we look at germs, we don't just think of them as being a particular disease-causing agent, so they don't just cause diseases, but we can know that Salmonella, for example, would be Salmonella enterica, and that's how we talk about microbes. They've all got different shapes under a microscope. So this is what I want to show you here. What you can see here is MRSA. This is what I was talking about before. MRSA looks like that under a microscope if you magnify it. So it's got this little structure or shapes like little balls. The same thing with this one here. This bacteria is looking like a little rod, and you see the same shape is over here. Exactly the same shape. And again, we've got other microorganisms that are really, really similar. Bacteria are very, very different to viruses. So I'll give you an example of this. This is a nice example of a virus. This is what it causes flu, so influenza virus. And again, it should be quite clear to see that that's very different to this particular bacteria. So that's a virus and that's a bacteria. They have different shapes and they do different things. Viruses are much smaller than bacteria, but they both cause infections, and that's something you need to know. The kind of infections that we're talking about now are things like cuts. So think about when you've had a cut and it goes a bit septic, so that means you've got an infection and it's infected. Sometimes pus can come out of it. So that's interesting because that would be from this particular bacteria called MRSA, Staphylococcus aureus. Again, most of you would have a sore throat. If you look at it really closely, you can see bacteria on the back of your tonsils or the throat. I know it's really, really disgusting, but it's really good for me to show you that that's how infections happen. So you can get bacteria growing there. And if I was to do this in the laboratory, you'd be able to see the bacteria on an agar plate. So what we do, which is really interesting, we get bacteria and we grow it on jelly. So you can even go and do this at home. You can go and get some jelly, put it into a bowl, get some yogurt and put it onto the jelly and put it into a warm environment for a couple of days. And you might see bacteria growing, which is really exciting. You can also do this with your hands. So this is something for you guys to go and do at home. You can get a slice of bread, put your hand on a slice of bread, and then seal that slice of bread in a plastic bag and just leave it in a cupboard for about a week. If you open that cupboard up again, and you can see your bag with the loaf of bread on it, you'll actually see loads of fungi and bacteria growing on that bread from your dirty hands. Okay? So little things for you to do at home. So when you have an infection, you need to have it treated. It's got to stop going further in your body. So say I had a cut over here, the last thing you want is it to be getting worse. And how do we do that with bacteria? Well, we stop bacteria by using something called antibiotics. I'm sure all of you may have had antibiotics. The most common one is penicillin, right? Most of you might have had penicillin. And what that does is just stop the infection, and that's what we want. It's really important. You don't want an infection to carry on. It will make you very, very ill. But before antibiotics were invented, these bacteria killed a lot of people. So I'm talking about maybe 100 years ago. 100 years ago now. Over time though, we invented loads of new antibiotics, we found loads of new antibiotics, and all of these bacteria that we've got and these diseases, we're able to treat them. And that's wonderful, it's really helpful. It means that we can actually help other people and stop people from dying. But bacteria are fighting back. Things are changing. What's happening now is that bacteria can actually survive antibiotics. So what does that even mean? It means that bacteria just don't react to the antibiotic. The antibiotics don't do much anymore. If you're thinking about this in a scientific way, the science is that when you have lots of germs, maybe one or two are resistant or can fight back and fight the antibiotic. But when you use an antibiotic, sometimes one or two will still survive. So it won't kill all of the germs. It'll kill maybe 80 or 90% of them. So if you had 10 germs, it will kill 8 of those 10 germs. So you've got 2 germs left that are going to carry on surviving. And those 2 germs can carry on growing and growing and multiplying and multiplying. And when they multiply and multiply, that means they're taking that fighting action and carrying that fighting action on. So it means the antibiotics just won't work and those bacteria fight back. What does that mean for us? Well, it doesn't bode very well. It doesn't mean it's not particularly good. It means that infections are going to be harder to treat. You can't just go to your doctor and say, I've got an infection, can you please give me an antibiotic? It's not going to be that simple. What's actually happening is that antibiotics are very special medicines. There's only very few of them left, so you have to treat them like they're very precious. You have to take care of the ones that do work, that are left. We need to look after our medicines and we need to use them properly. It's really important. Imagine if none of our medicines worked anymore, then we have a lot of people who are suffering. We don't want that, and scientists are doing their best to make sure that that doesn't happen. But it is happening, and I think you guys need to know that. When I talk about climate change, it's really linked to antibiotics and the fact that they don't work anymore. You might be wondering why, and why I'm bringing climate change into this. Climate change, for those of you that don't know, is when the planet is starting to heat up. And as the planet heats up, temperatures are rising, so it's getting hotter. That means it's not the same as it has been before. Infections become more common, so germs survive better when it's hotter. You can see about these particular germs here. When it's a hot environment, they'll just keep growing and growing and growing and multiplying and multiplying and multiplying. The more they multiply, the more that they start to infect people. And that's because they survive better in hotter climates. But at the same time, more and more people on the planet. That means our population is increasing. And what do people do? Well, people poop. Everyone poops, right? Has anyone ever thought of where our poop goes? Some of you might be thinking, it might just go in a tube and it might just go down the toilet. Well, after it goes down the toilet, where does it end up? I'll tell you where it ends up. It ends up in the sea. That's the final place where it ends up. Sometimes it is treated, but a lot of the time, it just goes in the sea as raw sewage. What does that mean? Well, if everyone's pooping, the sea is going to be full of poop, which means the sea is going to be full of a lot of bacteria, which isn't great. Can you imagine that? The sea is often really dirty too. When you've got the sea, you know that the sea has currents. The currents move around and the bacteria move around with those currents. As the planet heats up, you get more and more currents, and that means the bacteria will keep moving around different areas of the planet. It's making things worse. It means that we are getting bacteria going from one end of the planet to the other end of the planet. And half these bacteria are fighting back with the antibiotics. So what I'm trying to say is they are fighting the antibiotics. They are resistant to the antibiotics. The antibiotics don't work for these bacteria, and they're spreading across the globe. By 2050, we think there'll be 9.7 billion people in the world. Can you imagine 9.7 billion people pooping? Everyone needs to poop, and everyone needs to make sure that their poop is put in the right place and it needs to be treated, but that can't happen. It just won't happen with that many people. It's making things so much worse. There's so many things we can do about this though. I know that it sounds quite scary that we can say that these infections are going to carry on, and the fact that bacteria are surviving antibiotics and antibiotics don't work anymore. But there are things that you could do at home that I do already. So things that I do is I wash my hands properly, and we've got hand washing technique here. So usually you'd be washing your hands properly with soap and water for 20 seconds. Okay, so you'd be doing it this way, this way, this way, this way, as the image shows all the areas of your hand. And you can actually do this while singing happy birthday to yourself. It sounds really strange, but you could do that under a tap, happy birthday, and you've washed your hands for 20 seconds. So what I'm going to tell you today is how bacteria are on your hands. See what you can see here with my hands, and this glitter is going to act like the bacteria. So I'm going to put it all over my hands, so you can see that'll be my dirty hands, and this is the bacteria that's in the shape of glitter, because that's all shiny there. Now, when you use hand sanitizer, where do you think that bacteria go. Shall I show you? I'm going to put some hand sanitizer on. Right? I'm going to gently wash my hands. See, it's all right. It's very wet. Right. Where's the glitter gone? Is it still there? Because I can see it's still there. That's exactly what's happening when you've got your bacteria. They're still on your hands. This is why it's so important to wash your hands and make sure that you've taken all this glitter off. So the only way you can do that is by washing your hands with soap and water. It's the best thing you can ever do. Hand sanitizer is okay if you're on the go sometimes, but really you need to be washing your hands regularly in the day. Another thing is if you get antibiotics, make sure you take them properly. So a lot of people take a couple of days worth of antibiotics. Don't do that. You're making the bacteria fight back better. They're getting stronger and they're going to fight back more, which means that we won't be able to treat them. So if you eat your antibiotics properly and take them properly, then we'll kill the bacteria. They won't survive. Don't use antibiotics for coughs and colds. Coughs and colds, we can often fight them ourselves. We don't need these extra pills to help us. So try and use other ways to survive a cough and a cold. What are scientists like me doing about it? That's what you're here today. We're doing a lot. There's a lot of people working all across the world trying to solve this problem because this is a huge, huge problem. Can you imagine a lot of people across the world have infections, and if antibiotics don't work anymore, it means a lot of people are going to suffer. So some people are trying to find new antibiotics, which is really amazing, and we can do it, but it takes a really, really long period of time. I'm not doing that. What I'm doing is I'm trying to make new tests. So that means if we can find patients or people that have infections really quickly, we can help treat them better and treat them more quickly and help save more people's lives. Some people are making things like vaccines. So vaccines are basically injections that you can have that stop the bacteria from carrying on growing. Okay? So it makes your immune system work better. But what I'm all about is disinfection. It's one of the things that I absolutely love. I love cleaning, and when I do my microbial work and I work in the laboratory, I'll take my bacteria and I'll take my disinfectant and I'll start cleaning it. And disinfectant kills bacteria. Some bacteria survive better with certain disinfectants, some don't. So not all of them will die, but my research is to make sure that they will die when a disinfectant's put on them. So that's what I do in the lab. So if you think about things like masks, a lot of us are wearing masks of late. That's the reason, because we're trying to make sure that we don't contract or get COVID-19. It's the same thing with bacteria. So imagine you've got this mask and it's dirty. I'd clean it with soap and wash it, or I'd use something called ethanol, so that's alcohol, that's at 70%. That means 7 out of 10 of it is made of alcohol, and that will also clean it, and that's what I'm trying to do. So one of the great things that you can do is make sure that everything's clean when you've got dangerous bacteria around. And I do this with hospitals, and that's really, really important, because when you go into hospital, you don't want to get an infection. And a lot of people seem to get infections when they go to hospital, which isn't great either. That's basically what I do in a nutshell. I wanted to thank you so much for listening to me today. What I want you to think about is what you've learnt today. Have you learnt what a superbug is? Do you understand what I've just talked about? Do you know what an antibiotic is? If you do and you think you know what I've been talking about, can you perhaps share that with family and friends and tell them what you've learnt today? Thank you so much for listening. It's been great talking to you. I'm Tina. If you've got any questions, please feel free to ask them to me. Thank you.